Hey everyone, my name is Gaurav. Today we have an exciting project to share with you. We will be showcasing how to build a complete DevOps pipeline using Git, GitHub, Jenkins, Docker, and Kubernetes. So let's get started. But before we get started, let's quickly recap what each tool does. Git is a distributed version control system that allow multiple developers to collaborate on a project. Second, GitHub is a web-based platform that hosts Git repository and provide collaboration features. Third one is Jenkins is a open source automation server that helps with continuous integration and delivery. And fourth is Docker is a containerization platform that allow you to package and deploy applications. And in last, Kubernetes is an orchestration tools that help manage and scale containerized applications. So for this, first we need to push our code on GitHub. Okay. Here is as you can see, here is my code in CI/CD project directory. Let's ls space hyphen ltr, and here is my code. And now let's check git status. What is git status? As you can see, here is some untagged file. Let's add them with git add space dot. We have added the untagged file successfully in staging area. So let's commit them. Git commit hyphen m and ci/cd underscore project. Inverted comma. Our code is committed successfully. Let's check the remote repository added or not with git remote space hyphen v. As you can see, there is no remote repository added. So first we need to create a new repository. So as you can see, here is my GitHub profile. You can follow me on GitHub. Here's my GitHub profile. Let's create the repo. Click on new. Then we will insert our repo name. In my case, it's ci hyphen cd underscore pipeline project. So underscore project, and in description you can add anything, whatever you want. So in my case, it's ci/cd pipeline, and create a new repository. So as you can see, our repo is created successfully. Here is my repo URL. I have to copy my repo URL and I have to paste here with git remote space add space origin, then URL of my repo. Now if I command git remote hyphen v, it's showing my repo URL. So we have successfully added our repo as a remote repository. Now it's time to push our code with git push hyphen u origin master. So master is my default branch, And before that, we have to provide uh, our username and our access token. So my access token is in, I have saved in my slash root slash documents directory. So here is my access token. Let's copy the access token and paste in terminal. So we will insert our username. In my case it's Gaurav XO, and we have to paste our access token here. So we have successfully pushed our code on GitHub. If I refresh the tab, as you can see, our code is successfully deployed on GitHub. So our code is successfully on GitHub. It's time to create Jenkins CI/CD pipeline project. But before that, we have to start Jenkins with systemctl start Jenkins command. So as you can see, here is my Jenkins dashboard, and my Jenkins is running on local network with port 8080. It's my local network. So if I want to access my Jenkins out of my network, I have to forward the port 8080 with ngrok. So in my downloads, I have to set up ngrok. So here is my ngrok. Start the ngrok with /ngrok http, then port 8080. So ngrok, here is my port forwarded IP. Let's copy and paste in new tab. You can see we can successfully access our Jenkins dashboard out of our local network. So create new item, then enter your item name. In my case, it's CI minus CD pipeline underscore project. Choose freestyle project and then click on OK. So in description, you can add anything. In my case, it's CI/CD pipeline project using Git minus GitHub minus Jenkins minus Docker 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 minus Kubernetes. Click on GitHub project. Finally, it's a GitHub project. We have to provide our repo URL here. So paste here. Then in source code management, select Git, then repo URL, paste here. So here you have to provide your default branch name. Here is my master branch, and same here, here is my master branch. Now we have to select GitHub hook trigger for Git SCM pooling. Then we can save our project. Before build the code, we need to set up some setting in our GitHub. Click on settings and under settings choose developer settings and under developer settings click on token. Now you can tag your token. In my case it's ci/cd pipeline project. Choose 90 or 30 days, whatever you want, and click on all options. And click on generate token. So let's copy the token and for our convenience we should save our access token. So I'm going to save my access token in the root documents directory. So as you can see I have saved my access token. So let's copy the token and now we have to go to the repo settings and in repo settings on webhook click on add webhook and in the secret section paste your secret access token and in payload URL we have to provide our ngrok IP. So let's copy the IP and paste in payload URL. Then slash github minus webhook slash, then click on add webhook. Now make sure check mark should be there. So our Jenkins and GitHub is successfully integrated. So it's time to build our code. But before that, I want to show you in workspace, the workspace should be empty. In slash var slash lib slash Jenkins slash workspace, you can see this is empty. Now build the code. You can see our code is building now. Within fraction of second our code is built. Let's refresh the tab and in console output you can clearly see finished code is success. So to access the code we need to install some requirements. If I show you in readme file you can clearly see We have to install node.js, npm, and after that we have to set up npm. So I have already installed node.js in my system. You can simply install by the command install node.js. So now I have to set up npm install only. So you can see it's throwing an error, 6 vulnerabilities is found. So let's fix them with npm audit fix hyphen hyphen force command. So vulnerabilities is fixed. It's showing 0 now. Now type node app.js to access the code. Here is clearly mentioned. And last we have to command node app.js. Here is our IP and port 7000. With this help, with this IP we can access our code. So our code is working properly. Basically it's a to-do app. You can add your to-do list here. So our code is working properly. Let's do some changes in our code. We will edit the code in our local machine. So cd desktop / git / cicd project, and I want to edit views folder. So I want to edit to do.ejs. So I will open to do app EGS in vi editor. Let's erase is skilled DevOps engineer and save. Now we will check its status. It's detected the modification in todo.ejs. So let's add the changes with git add dot, then git commit -m and changes. Now push the code with git push -u origin master. So my default branch is master branch. Now you have to provide your username and your access token. So my access token is in a root/documents. So here is my access token. Let's copy and paste in terminal. So we have successfully pushed our code on GitHub, and if I open my Jenkins dashboard, the code is building automatically. So as you can see, the code is building automatically. This is a very good example of continuous integration, continuous delivery. So I have made some changes in our code, and Jenkins clearly easily detect the code. So here is, you can see the changes is highlighted here. Is skilled DevOps engineer. So in browser tab, the changes should be there. Yeah, you can see. Now it's time to build Docker image. So all things will be same as it is. Now in builds tab, we have to choose execute cell, and in execute cell we will provide some command docker build dot hyphen t, the name of docker image. In my case it's to do app, then docker run hyphen d hyphen name of my container. In my case it's my web, then hyphen p for port 7000 colon 7, and name of docker image to do app, then save it. But first we will check the status of docker with systemctl status docker command. We will verify docker is running or not before building the code or docker image. So our docker is running. Let's check the docker images. So there is no docker image with to do app name. Now let's build our docker image, and in workspace also empty. So let's build the docker image. So docker image is building now. As you can clearly see, the Jenkins is cloning repository in my local machine and building the docker image. Size is 22 MB. So our docker image is successfully created, and finish code success. So our Docker image is successfully created, and in workspace, new directory is created with the name Docker deployment. Let's check Docker images. Our to-do app is showing here. If I command docker ps, our container is running with 7000 port and container name is my web. And if I command docker container ls, you can see the container id, image, command created a 1 minute ago, and status, then port. Now it's time to access our code, docker deployed code. So as you can see, it's working fine. So our code is running perfectly. Now it's time to explore the power of Kubernetes by diving into Kubernetes deployment, node port service, and horizontal autoscaling. These features are essential for managing and scaling applications in a Kubernetes environment. So let's get started. But before we begin, let's briefly recap what Kubernetes is. Kubernetes is an open source container orchestration platform that helps automate the deployment, scaling, and managing of containerized application. At the heart of Kubernetes deployment is the concept of pod. Pods are smallest deployment unit in Kubernetes. They are building blocks of our application deployment. So to start the process first, we need to start minikube with minikube start command. We can check is there any pod and service is running or not with kubectl get pod service -o void command. To deploy application in Kubernetes, we use YAML file to describe the desired state of our deployment. Let's take a look at a sample YAML file for basic deployment. Here is my YAML file. In this YAML file, we have defined deployment and the number of replicas, the container image, and other configuration details. We can also specify resource limit, environment variable, and other parameters to fine-tune our deployment. Now, going to change my container name. Currently, my container name is Goro. I change with web app in image. I have put my Docker Hub deployed image. Our container is running out port number 7000. Once we have our YAML file ready, we can use kubectl apply -f and name of your YAML file command line tool to create and manage our deployment. Let's walk through some common kubectl command for working with deployment. We can check status of our deployment using the kubectl get deployment command. This command provides information about the number of replicas and current status and other relevant details. Scaling our deployment is other crucial aspect. With kubectl get pod, service -o void command, we can check number of pod and service running. So now, if you want to more about a pod, we can check with the help of kubectl describe the name of your pod. You will find every details of your pod like events, volumes, about the container ID, image, image ID, on which port your pod is running, state of pod, IP, and etc. Now let's move to node pod service. By default, Kubernetes set up an internal network for pods to communicate with each other. However, sometimes we need external access to our application. That's where node pod service comes in. To expose our deployment to the outside world, we create a node pod service. This service map a pod on each cluster node to a pod on our deployment, allowing external traffic to reach our application. But before that, I want to show you service list with minikube service list command. You can see there is no service running and URL section is empty. Now let's create a service with and expose the port number 7000. For this, we will command kubectl expose deployment -- name is equal to hps minus svc. In my case, it's hps. In your case, you can give your desired name to your service. Then port is equal to 7000 because our port is running on port number 7000. Then type is equal to node port. N and P should be in capital. Now, if I check service, you can see there is a new service added with name hps-svc. Now let's check minikube service list. Also there is new service is added and URL section appear with a new IP or URL. Let's try to access our code with this URL and we can successfully access our to-do app. So in first tab we have our Docker deployed image and in second tab we have our Kubernetes deployed to-do app. We can monitor our deployment with watch kubectl get all command. And we can scale our deployment up or down using the kubectl scale command. This allows us to handle increased traffic or reduce resource consumption as needed. Finally, let's explore horizontal autoscaling. As our application's demand fluctuates, we want to scale our deployment automatically to handle the load efficiently. To enable horizontal autoscaling for our deployment, we use the kubectl autoscale command. This command creates an HPA object which monitors the metrics and scales the deployment accordingly. The command is simply kubectl autoscale to do app then -- CPU-% is equal to 2. I have mentioned 2 here to show you HPA. Then hyphen hyphen minimum is equal to 1 and hyphen hyphen max is equal to 5. In this YAML file, we define the maximum and minimum number of replicas, the target average CPU utilization and other parameters. Now, as you can see at the bottom of terminal, new row is added, HPA is enabled for our deployment. Suppose some new user open app at same time, so load will increase on server. In that condition, Kubernetes will create new pods automatically. If user decrease, Kubernetes will terminate the unnecessary pod automatically. And that concludes our project on deploying the to-do app using Node POS service horizontal autoscaling in Kubernetes. We have successfully built a scalable and accessible application that can handle varying level of traffic and demand. By utilizing the Node POS service, we have exposed our to-do app to external user, allowing them to interact with the application through a specific port. This makes it easily for user to access and utilize the functionality of our to-do app. In addition, we have implemented horizontal autoscaling to automatically adjust the number of replicas based on resource utilization. This ensures that our to-do app can efficiently scale up or down, optimizing resource allocation and maintaining optimal performance. So throughout this project, we have walked through the process of configuration the Node port service, exposing our to-do app to the outside world. We have also set up horizontal autoscaling based on metrics such as CPU utilization, providing seamless scalability as the demand of our application fluctuates. And last, I hope you found this project helpful in understanding how to deploy application in Kubernetes using Node port service, horizontal autoscaling. If you have any question or suggestion for future project, please let me know in the comment below. Thank you for joining us today and we will see you in next project video. Happy deploying with Kubernetes. Bye and take care.